Okay, so on this one, we have NASA is launching a rocket at t equals 0 seconds. Its height in meters above sea level as a function of time is given by that. All right, assuming that the rocket will splash down into the ocean, what time will splashdown occur? And then how high above sea level does the rocket get at its peak? So basically, this equation right here is an x squared. It's t squared, same thing. It's an x squared equation, a t squared equation. You know what those are? Those are U-shapes. We've graphed a bunch of x squareds in this chapter, and they're all U-shapes, either going up or going down. And how do you know which one it is? Well, it's got a negative in the front. So that means it's going down. So negative in the front, so of the t squared means it's a U shape that looks like that. It's a U shape going down. So, okay. So you don't have to graph it, not required at all, but it might help you to know that therefore, basically what we're looking at is a shape that kind of goes like this. Starts here, goes there, has a peak in the middle. So that's basically the deal. Now, I could continue the U shape, like this. That's the entire U shape. But all we care about is, where it starts and then how it goes forward. And then it lands in the ocean right here. So, okay. So there's the 2 points we care about. This one is the maximum. And this is where it lands in the ocean. Of course, this one's where it starts. Okay, and this is, how this works. This is the x-axis and the y-axis, but in our case, the x has been replaced with t, so I'll just say this is the t-axis, and the y is what's in front, and we're calling that h. So we really have, I'll say x or t, and this one is y or h, height. So really, we're doing the graph height versus time, because height is our y. Remember, what's in front is always y. The function letters, f of x, g of x, h of t, whatever, that's y. And then our variable, instead of x, we're using t. So it's height versus time. Okay, anyway, so they want to, when does the rocket splash down? Right here. Here's where it splashes down. What do you know? So let's bring down this part A first off. The rocket splashes down when what? When the height is 0, right? When it hits the ocean, its height is 0. So take the formula that they gave us. Height equals minus 4.9 t squared. Grabbing it up there. Plus 367 t plus 171. Just grabbing this formula right here. Bring it down, and then just grab that 0 and plug it in right here. Just pop in a 0, because that's what we're trying to find. When is the height 0? When does it hit the ocean? So then solve for t. Solve for t. Well, how do I solve it? Well, it's a t squared equation. Whoops, it's a t squared, regular t, no t. It's a t squared equation. How do we solve those? Well, we use the quadratic formula, huh? So let's just dive into the quadratic formula. So I'll do that now. So it's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. And so, oops, let's do that. Okay, so I'll go negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And I'm going to just plug in. Now, what are a, b, and c? Well, a is the number in the very front, then b is what comes next, then c is back here. So plug in a negative b, 367 plus or minus square root of b squared, 367 squared minus 4 times a. Now, a is minus 4.9. Don't forget about that little decimal there. That's not 49, that's 4.9, right? Minus 4ac all over 2a. And again, that a is 4.9. 4.9. That's half of gravity in the metric system anyway. It's a physics thing. This is actually an actually accurate physics formula. This is the real deal that physicists use, engineers, to calculate the travel of an object that doesn't have its own engine, right? Yeah, enough said. Let's crank it out. So, all right, so we'll go from here. So I'm going to hit the buttons on the calculator. So I have minus 367 plus or minus. So now inside there, I'm going to have to have a lot of messy numbers. So 367 squared, I'm getting 1, 3, 4, 6, 8, 9. And now over here, look, we have minus times plus. So 2 minuses is plus. 4 times 4.9, just do 4 times 4.9 times 171. On the calculator, I'm getting 351.6. On the bottom, 2 times minus 4.9 is minus 9.8. I just calculated those numbers, right? I just did squared on my calculator, got this. And over here, I did minus times minus, so that's plus. Then I just multiplied 4 times 4.9 times 171 on my calculator, got that 3351.6. The bottom, 2 times negative 4.9, negative 9.8. All right. So now, so if you get more decimals, if you get like a whole bunch of decimals, just use 4. At most, no more than 4 decimals is needed. All right, let's keep going. Let's see where this ends up taking us. But I can do it right here, I think. All right, so I'm getting minus 367 plus or minus. Okay. I'm getting, oops, 138040.6 in there over minus 9.8. Okay, so that means we need to break these into the 2 different options, right? So we have minus 367 plus the square root of that 138040.6 over minus 9.8, or the other option, or the other option, which is minus 367 minus 138040.6 over minus 9.8. So you see what I'm doing there? I just did the plus and the minus, right? This was plus or minus, so I went over here and did plus. Then I went right here and did minus. I did the 2 different options. Calculate those on your calculator, which I will now do. And I'm getting for this one, negative 0.4630. Cross that out. This is time. By the way, remember, we're solving for time. Come back up here, right? This was a t-squared equation, t-squared. So we're solving for time. So we're saying that the time equals negative. That's back in time, right? So throw that away. That's not it. Let's do the other one. So the other one's going to be our answer. So let me go back and do it. The other one. And I'm getting 75.361. Just use 4 decimals. So that's the time. So that's the real answer. That's the time when the rocket splashes down. So that's our answer to the first one. 75. They don't say how many decimals, do they? So just give them 4. That'll be plenty. They don't say how many, just give them 4. 75.3610 seconds, 75 seconds before that rocket splashes down. So there's the first part. Now the second part of the question, they ask us, how high above sea level does the rocket get at its peak? Well, here's the peak right here, the maximum, right? That's when the rocket is at its highest point. How do we find the maximum? So let me do that right here. Okay, so at the peak, max Remember the formula for the peak? So basically this is a U-shaped graph, isn't it? It's a U-shaped graph, and we want to know the maximum, the peak, the highest point for the rocket. That's the middle. That's the middle of the U-shape. At the peak, the max of an x squared graph, a U-shape, right? How do you find that max? It's the center, or also called the vertex. And the formula is x is negative b over 2a. That's the formula for finding the maximum, the peak. For any U-shaped graph, we've done that before. It's x equals negative b over 2a. So I go back to the formula and I grab the b and the a again. Here's the b, here's the a, right? 367 and negative 4.9. So it's negative 367 over negative 2 times negative 4.9, right? So I plug in the b, plug in the a that I got. And so then that's what, minus 367. The bottoms would be minus 9.8. Divide that on your calculator. 2 negatives make a positive. I'm getting 37. Now the decimal goes on. Now how many should you use? 4. So use 4 decimals, you'll be safe. Don't cut it shorter than 4. It'll mess you up. So my decimal goes on and on and on and on. I'm just going to use 4 decimal places. Now, because that's not the final answer yet, that's the x, but what did they ask for? Come back here. They said, how many meters above sea level? That's height. They want height, huh? How high up is it? How many meters above sea level? How high is that rocket at its maximum? So to find height, I got to plug into the height formula, don't I? So now, plug x, or t, whatever, that's really t, whatever, xt, whatever, into the height formula. What's the height formula? H equals minus 4.9 t squared, I forgot the rest, plus 367t plus 171 plus 367t plus 171, did I get that right? Plus 367t plus 171. Right, so plug that in. So take that value and plug that in. It's actually t, really. Plug it in right there for t and right there because x is really t, it's time. So then the height will equal minus 4.9 times 37.4489 squared plus 367 times, again, 37.4489 plus 171. So I'm plugging in the time and then hit the buttons on your calculator. So this isn't easy. It's a lot of calculation. And I'm getting 7042, again, 4 decimals, 0.8877. There's the height. That's, I assume, feet or whatever. The feet, meters, I guess it's meters, whatever. There it is. That's the height of the rocket. That many meters. So that's the maximum height. That's as high as the rocket goes. That's how they figure these things out. These are the actual physics formulas for how they figure these kind of things out. So let's recap. What did we do on this problem? They gave us an x squared graph, an x squared equation, but it's a negative x squared or negative t squared, which means it's a U shape upside down. Then they asked us to find where it splashes down in the ocean. That's where it splashes down, the height is 0. So I took the height formula and I plugged in 0 for height. And I had to solve the x squared or t squared formula, which means quadratic formula. I plugged in a, b, and c, cranked out the quad, got 2 answers, threw away the negative. That's back in time. So just there's the time when it splashes down. And then the second part said, well, okay, what's the highest point the rocket reaches? The peak. To do that, that's the center of the U shape. The center of the U shape is the formula x equals negative b over 2a. We've seen that before. That's the center of a U shape. So I plugged in the b and the a, cranked that out, got that answer for x or t, same thing. But then I have to plug that into the height formula because they actually asked for the height. This right here is the time. This is the time when it's at the peak. So after 37.4489 seconds, it's at the peak, it's at its highest, but they want to know the height. So then I had to plug that time back into the height formula, plugged it in, cranked it out, there it is. The maximum height is 7,042.8877 meters. Make sure you're using 4 decimals all the way through the problem. And there we go.